Our discussion today to pee or not to pee, a Shakespearean study of urination. And when we do this, we're talking about the urinary system, also known as, or as a larger system, also called the excretory system, involving sweat glands, oil glands, anything that excretes to the outside. But for the urinary system, our major organ is the kidney. There are three other organs, the ureters, the urinary bladder, and the urethra. Ureters are these tubes that bring urine from the kidney to the bladder, and the urethra is the tube to the outside. Kidneys are located just up under your, kind of behind your bottom of your rib cage in the middle of your back, embedded in fat and muscle. They're not all the way protected by your ribs, which sometimes is an issue. But this is a cross-section of a kidney on this side, and you can see how the tube that goes to the outside, this is the ureter here, that will bring urine to the bladder, and so on. Functions of the urinary system. Number one is to eliminate waste products, things called nitrogenous waste made of nitrogen, mostly, as we'll see at the end, produced by a breakdown of protein. Okay, when you eat protein, one of the things you do is you break off amino acids, which are made of nitrogen. Those can be toxic to you, poisonous, and so your body gets rid of them. Other toxins that are produced just by things you eat or by your liver breaking things down, drugs are eliminated in your urinary system. And then the other thing the urinary system does is to regulate aspects of homeostasis. Remember that homeostasis is the stable internal environment, the fact that your body has a stable internal environment. Water balance is the major one. Electrolytes would be things like sodium ions and chlorine ions, potassium ions. Anything that dissolves into an ion is an electrolyte. Gatorade, you may have heard that term when you see Gatorade, is it in you? And you get these green people or whatever because they're getting their electrolytes. Red blood cell production. Not produced here, but produces hormones that tell the bone marrow to produce red blood cells. This is the one we're going to talk about more than the others. And I have a formatting problem. So let's talk about what the kidney does. The kidney's job is to filter the blood. And it does it by filtering waste. It filters waste out of the blood. In general, blood comes in on the renal artery, is filtered by something called the glomeruli, actually by the nephron, which we'll talk about. And then clean blood goes out of the kidney on a vein. The waste products, maybe I should draw that in yellow because they tend to be yellow. The waste products are passed out and go out in urine. So another view of a cross-section of a kidney. Here you see the blood vessel coming in and then going out. Okay, so dirty blood in, clean blood out. And then all this part here and here and here and here contain nephrons, which actually do the filtering of the blood, and urine goes out this tube. You don't need to know the terms in there. The unit of function in the kidney is a nephron. And what a nephron does is it filters blood by basically taking everything except blood cells out and putting back what you need, called reabsorption. Now let me give you an example. The example I like to use is that it's like you cleaning your room. Your mom's nagging at you, clean your room, come on, Billy, clean your room. Your room's so dirty, I can't see the floor. So you clean your room. And you decide, because you're in a fit of rage at your mother for nagging, so you take everything out of your room and you throw it in the hallway. Except for maybe your bed, because you can't lift that, and a dresser if you have that. Maybe you got a TV that's a little too heavy for you, so you take it. Those things stay. Everything else, clothes, toys, if you still have toys, video games, whatever, books, all that stuff, just chuck in the hall. Okay? That's kind of like filtering blood. You take everything out, throw it in the hall, and then what you do is you take back in what you need. So, you know what, I need my clothes. So you take those back and you put them in the drawers, hang them in the closet. You take back in your books because you like reading books at night. You bring your lamp back in. You bring your clock back in. All the stuff you need, and you leave everything else in the hall. What's left in the hall will go out as waste. You're going to throw it in the trash. Taking everything back what you need is what the kidney does. It reabsorbs it back into the blood, in the nephron. That's a simplified example. Okay, here's a view of a nephron. You can ignore these terms. You're not really going to have to know them. Okay? Blood comes in an artery here, and I'm drawing it with the yellow pen because I don't feel like changing, and it's squeezed in something called the glomerulus. The waste products, this would be like the hallway. The waste products are out here in the hallway in this tube. And then the blood vessels surrounding this take things back that you need. Whatever you don't need ends up going all the way through this tube, all the way through this tube, all the way through this tube, out here, and then eventually out the bladder. So the general idea is this, that blood comes in and is squeezed. It's squeezed in this thing right here. It doesn't look like it's squeezed, but this artery coming in is bigger than the artery going out, which makes it squeeze. Everything goes into this tube. This is like the hallway. The blood coming back down here then is like your room, and you put back into the blood the things you need. What do you need? Well, you need sugar, you need water, you need some salt, and other things are put back. That's called reabsorption. At the end, sometimes there's stuff still in the blood that you need to get rid of, like drugs, and so those are secreted into the urine. This is why they do drug tests, urine tests for drugs, because drugs are excreted in your urine. So what don't you need? Again, nitrogenous waste products. That's what you're going to get rid of. Here are some. Excess water is what you're going to get rid of. It's not reabsorbed. So again, a different view of the same idea. Okay, up here in a nephron, blood comes in and is squeezed in this little thing called Bowman's capsule. Urine passes into the tube. Okay, water comes out. Back into, this is the blood, it doesn't show it over here, but water is being reabsorbed into the blood. Salt is being reabsorbed into the blood. Salt is being reabsorbed into the blood. Bicarbonate ion is being reabsorbed into the blood. Actually secreted, but same difference. It's going into the blood. And here is where some drugs and poisons are put out of the blood and into the urine. And then the urine is going to pass down this tube and eventually out of the body. All this is happening up in here, and the urine, I'll draw the yellow line, ends up in there. So when it ends up in there, where it's eventually going to go is to the bladder. Urine to renal pelvis, down the ureter, and out to the bladder down here. Let's take a look at that. So again, here's our kidney. Here's our nephrons all up in here producing urine. Urine is going out into here and then down this tube into the bladder. We have here are the artery and vein. Artery going that way, vein going this way with clean blood. Here's our bladder. Thankfully, we have a bladder. If we didn't, we wouldn't be able to store urine, so we'd have this constant drip of urine. It holds about, just for information's sake more than anything, it holds about a 20-ounce bottle, okay, 600 mils. It starts to hurt a little bit when you have 400 mils of urine in there, when you stretched it that far. It's elastic, so when it's stretched, and we'll come back to this, it sends a message to the brain, gotta go. And then urine is forced out this tube called the urethra to the outside. Now about that, micturition is the word. Micturition is the word for voiding your bladder or urinating. Remember, we talked about this. Some of you had me at the very beginning of this year. And in my classroom, we have the no bathroom pass policy, and I explained to you that you have two sphincter muscles in your urethra. the tube to the outside. The internal one is relaxed after the bladder is stretched. And so the bladder gets stretched with urine, it relaxes a little bit. There's activation by a brain sending a message to the spinal, or the bladder sending a message to the spinal cord and back. That's what opens the sphincter. Okay, but then your brain gets the feeling, you got sensory nerves in your urethra that say, hey, I got some urine here, it's got to go. Well, when you were a baby, you would just let it go. You didn't learn. Now you've learned to hold this one, the external urethral sphincter, shut. And so you have to, when it's time to urinate, relax that and let urine flow. And again, I have a poor setting here, sorry. So, about water. Your total body water volume is actually 40 liters, which actually makes up about 60% of your body weight at your age. Okay? Much of 40% of that is inside of the cells. Okay, your cells have 25 liters of water in them. The rest is outside of your cells. Okay, so about 20% of your body weight is outside of your cells, about 15 liters. 12 liters of that is between your cells, what's called interstitial fluid. The rest, 3 liters, in your blood plasma. One of the reasons wrestlers can sweat off so much weight is because they have so much weight of water outside their outside of their cells, and they run and all their sweat stuff. What they're trying to do is lose weight. What they're really losing is water. They're losing their water weight. That's why it comes back so fast when they drink. So maintaining water balance. Just remember that we talked about this with digestion, or we're going to, depending on what class you're in. Water intake has to equal the output. Okay, so your body, that's homeostasis. You have to maintain the same. So what do you take? Ingested foods and fluids is a good way to get water. In fact, that's the major source of water. Water produced from metabolic processes. Anytime your body does a chemical reaction, not anytime, many times, water is a byproduct. Some organisms, like a kangaroo rat, rarely drink anything because they just use all the water they make from breaking down food and stuff. Sources for water output. Well, when you breathe, you get water out of your lungs. Some of it's lost in sweat. It can leave the body in your solid waste. Hopefully, of course, the less solid your waste is, the more water's in it, right? And so we talked about that earlier, that hopefully your waste isn't too liquidy. Otherwise, you're losing a lot of water. Urine production. That's the major loss of water. Okay, and that's what we've been talking about, is urine production. So remember then that if you have too much water, you have to get rid of it. And so you produce dilute or clear urine. Concentrated urine is produced if large amounts of water are lost. And if you think about this, you wake up in the morning and your urine is really concentrated. It's very yellow. Well, you haven't had any intake of water for the last 8 to 12 hours. And even though you're in bed, you're still breathing, and you're still giving off a little bit of sweat, but you're not getting rid of as much as you normally do during the day. So in your brain is a gland called the pituitary gland. It senses the amount of water in your blood. It has sensors. And if the amount of water in your blood is low, that means you don't have very much water running around. You need more. It secretes a hormone called antidiuretic hormone, which makes the loop of Henle more permeable to water. The loop of Henle is, remember on the slide previously, and you can review this on the video, where water goes out of the urine and into the blood. Well, now it's more permeable. That means more water can go out. So there's less water in the urine. You're keeping water in your body. If blood water is high, then no antidiuretic hormone is secreted, and the loop of Henle keeps water in the urine, and your urine will be clearer. Now, the interesting thing about this whole idea is that let's say you drank a lot of Mountain Dew today, or Monster, or something else. Okay, those contain caffeine. Caffeine is what's called a diuretic. That means caffeine does not allow water to be put back into the blood. That means more water will be in your urine, and so you'll pee more. It makes you go, as Mario says, makes you go. Okay? So you get the double whammy of drinking all that liquid and the fact that it's a diuretic. And then briefly on urine, we've already kind of talked about all of this, is that mostly water, the rest is mostly urea, the byproduct of protein breakdown by the liver. If it was birds and lizards, they produce uric acid, that white paste, which falls on your car. And one of the reasons you want to get off your car fast is the acidic properties of it can eat away at your paint. So, and there's other waste products. What shouldn't be in your urine is glucose. Okay, one of the tests for diabetes is a glucose test. Why glucose? Well, because that means that your body's not getting rid of all the sugar that's normally in your blood. There's being sugar excreted in your urine. That means it's way too high in your blood. Okay? You should not have any glucose or protein really being excreted in your urine. This is a sign of kidney damage when there's protein in there. And that's the end of our discussion of the kidneys.